Today, we are going to learn how to use the STEM Corrector software. Look at these icons, resembling elements of the periodic table. These are not actual elements, but different packages within the TEMDM software family. We need the STEM Corrector. Just click the icon, and here we are. The interface consists of two frames. In the left frame, we place a STEM image of our structure. In the right frame, we place essentially the same structure, but acquired with a 90-degree clockwise rotation of the scan direction. This is indicated by this rotated icon. Let's load a file in the left frame. Press Load under the left frame, and choose the image of a particle in its original orientation. And the same particle taken with rotation. Now I'll close and reopen the program to show you an easier way. Instead of pressing the Load buttons under each frame, click Load in the Project field. Then select two files while holding the Control key. You'll get the same result. You might wonder why the right image is outlined with a red border. This simply indicates that it is rotated. You can return it to the original orientation by clicking this Rotate Back button. Now you can see that there was significant sample drift to the left up. The particle is expected to be square, but it became heavily distorted during acquisition. The same applies to the right image, although the distortion differs due to the different scan direction. You can better visualize the differences between the images by clicking this eye icon on the left. Let's assume the drift is constant and try to recover the true shape of the particle. At the bottom, there is a panel of buttons representing the natural processing workflow from left to right. We have already loaded the images. Skip Stick for now and press Linear. You can see that the correct shape of the particle is restored. Click the I button again. How was this done? Well, rather evident assumptions. Cross-correlation detects the shift between the two images and corrects both, assuming a continuous constant drift. Notice that the edges of the images are now inclined due to deformation. The images are still displayed at their original size. If you want to see the full corrected area, click the Frame button. Clicking it again toggles to a minimal frame where empty areas are hidden. Although the shape is greatly improved, still there is a small mismatch. Then press Non-Linear Correction. This accounts for irregular distortions within each frame. It takes a bit more time than the previous correction step. Well, the convergence is acceptable. Click the eye again. Now the images match very well. The final processing step is to merge both images to improve statistics and accuracy. Press Merge and we obtain the summed image. Note the orange squares indicating the correction stages. You can always inspect previous states. You can also export any image in your preferred format. Currently, the Gatan format is selected in the settings. An even easier option is to save the display as a JPEG and paste it directly into your report. Press Snap. Finally, you might wish to save all images in a single file, intrinsic TEMDM format, in order to reopen the entire project later. Well, this was a first introduction to the STEM Corrector workflow. In the next video, we will explore additional examples and more advanced features.